In this video, I will talk about how to read percentiles. Percentiles of the normal, chi-squared, or students t. Let's say students t first. Students t and chi-square distributions. I talked about percentiles before briefly, but in this video I will show you in more detail of how to read the percentiles of these three distributions. Right? So first of all, I will start with the normal distribution, right? And as you know, let's take the standard normal distribution. For the standard normal, the density, I'm sure all of you know this, that the density of standard normal looks like this, right? Let's draw another picture the same. So this is the, excuse me for not being able to draw good pictures, but so what I have drawn here, although not perfect, is the density of a standard normal. So this is the PDF of normal, zero mean and variance 1, and the same thing here, the PDF of normal with zero mean, variance 1. Now, what I mean by percentiles is the following: that suppose you have a point here, right? And the area to the left of this point, that is this area here, suppose this area is equal to alpha, right? And then this point here is denoted by little z subscript alpha, right? And is defined as, is defined as phi inverse at alpha. So this is the notation to denote the percentile. And these are known as percentiles of the normal distribution, of the standard normal distribution, with the area of alpha to the left of it, right? Now, sometimes you want to have you want to take two percentiles, so that because it is symmetric, you can have percentile here and a percentile here, which is a mirror image of along this line, right? And suppose the area in between these two, that's this area here. Suppose this area is 1 minus alpha, okay? So that means the area in this and the area in this must add up to alpha, right? Now, because of symmetry, let's suppose that this area is alpha by 2. And also, let's suppose that this area is alpha by 2. Okay, so in this case, this point here, right, will be z to the area, the z of the area to the left of this point, which is 1 minus alpha plus alpha by 2, which is 1 minus alpha by 2. And the notation for this point, okay, is z of the area to the left of it, left of this, which is alpha by 2. And because of mirror symmetry, these 2 points must be equal in magnitude. So because of symmetry, because of symmetry, we must have z alpha by 2 equal to minus of this. Right? So what I'm saying is that this is minus of this point, right? So I hope you follow from this slide how to read. I mean, what the percentile means. So percentile is basically a point along the horizontal axis, such that the subscript is the amount of area covered by the left of that point. So here this is z alpha, here this is z1 minus alpha by 2, because you have an area of 1 minus alpha between these 2 points, an area of alpha by 2 beyond this. So 1 alpha by 2 plus 1 minus alpha is 1 minus alpha by 2. And for this point, this is z alpha by 2, because the area to the left of this point is alpha by 2. All right, now in the next slide, I'm going to show you how to actually read the percentiles of the normal distribution. And for that, you need a table. I think I showed you this table some while ago. This is the normal, this is known as the normal table, right? And you can use this table to read what I just described, right? So let me give you some examples. Examples, 1. Suppose you want to read z 0.9. So in other words, you want to read the value along the horizontal axis of the standard normal PDF, and to the left of that value, you have an area of 0.9. So what you need to look for in this table is this table here gives the area to the left. All this table, the big table here, right? So you need to look for 0.9 in the table. So let's see where we can get. See here, this is the closest you can get to 0.9. 8997, right? And this corresponds to a value of 1.208. So this is approximately equal to 1.28. Okay. Another example. Suppose you want to read 0.1. 0.1 is not in this table, right? Okay, so what you need to do is to use, you see, if you look at this table here, it only starts from 0.5 down to 1. It doesn't have 0.1. So what you need to do is to use the property that I just gave you, that is z of alpha is minus of z of 1 minus alpha. And this is the property, z of alpha is minus of z of 1 minus alpha. This is the property that I just gave you in the previous slide, right? So this is minus of z of 0.9. This we already know is 1.28, so this is minus of 1.28. Third example, suppose you want to find the percentile corresponding to this. In other words, you want to find the value along the x-axis, and to the left of that value you have an area of 0.99, right? So you need to, in this table you need to look for 0.99. So the closest you can get to 0.99 is this one here. Okay, all right, and the corresponding value is 2.33. All right, so this is approximately equal to this. All right, so this is how you read the percentiles of a normal distribution. You use this table here, which I think I showed you this before, this table, right? Okay, now next is, so far we've talked about the normal distribution. Now number 2, I'm going to talk about students' t distribution. Okay, so let me just give me a couple of minutes to draw some pictures. So suppose this is the density of those students t. So let me draw the axis. This is the axis, and this is the right. Okay, so what I have drawn is the PDF of a t variable with a degree of freedom. And the same thing here, PDF of a t variable with a degree of freedom. Right? Okay. Now, in the same fashion, like in the previous case for the normal distribution, we draw a point along the horizontal axis and call this T A, comma, A is the degree of freedom, comma, alpha, if the area to the left of this point, that is this area here, is equal to alpha, right? Okay. So this point is the point along the horizontal axis. So the alpha corresponds to the area to the left. And sometimes you want to have mirror symmetry. So suppose you take 2 points that are directly opposite to each other. This is 0, this is 0. And let's suppose that, sorry, my drawing is very bad here. Let's suppose that the area between these two, that is this area here, this area is 1 minus alpha, right? And if we want to have equal areas over here and over here, we will take this piece here to be alpha over 2, and the piece here to be also alpha by 2. Okay, so this point here will be the percentile of a t distribution with a degree of freedom, and the area to the left of this point is 1 minus alpha by 2. And this point here will be t with a degree of freedom, and the area to the left of this is alpha by 2. And because of mirror symmetry, because of the fact that the t has a symmetric PDF, right? These two are equal by magnitude, so by symmetry, right? Okay. Now, in the next slide, I'm going to show you how to read the values of these percentiles using the t-table. Right? So here we go. So there's something called the t-table. I think I showed you this before. It looks something like this, right? So let me give you a few examples on how to read the t-table. First example, suppose you want to read the percentile corresponding to 1 degree of freedom and an area of 0.9 to the left. So to read this, you go to the table, and the first column gives the degree of freedom. So you look for 1, which is this, and then you look for the probability 0.9, which is the first one. So this is 3.078. Example 2. Suppose you look for a percentile with 1 degree of freedom and a probability of 0.1. 0.1 is not in this table, so you need to use the property that I just gave you, right, by symmetry. Right? The property that I gave you is this: t of a alpha is equal to minus of t of a 1 minus alpha. This, using this. Okay. Right now, this is minus of t1 comma 0.9, which is minus of 3.078. Example 3. Suppose you want to read the percentile corresponding to 10 degree of freedom and a probability of 0.99 to the left. So to read this, you go to the table, look for 10 degree of freedom and a probability of 0.99, right? So that is 2.764. All right, so this is how you read the t-table, right? Okay. The next thing I'm going to talk about is the chi-square distribution. It's number 3. Right. So for that, it's gonna be. Let me first of all draw some pictures. So the typical shape of the PDF of a chi-square is like this. So this is what I'm drawing now. So this is the typical shape of a at the PDF of a chi-square. So the PDF of a chi-square variable with a degree of freedom, PDF of the chi-squared variable with a degree of freedom. Now, once again, suppose you take a point here, right, and suppose you have an area of alpha to the left of it. So this area is alpha. Okay, and then this point is denoted by chi-squared. A is the degree of freedom, comma alpha is the area to the left. Sometimes you may want to have more than one point, right? So suppose you have, say, one here, right? And the area between them, suppose the area between these two is 1 minus alpha. Okay, and so that means these two areas have to make up alpha. And let's suppose we choose such that this area is say alpha by 2, and suppose this area is also alpha by 2, right? So in this case, this point here will be chi-squared with a degree of freedom, and the area to the left is this plus this, which is 1 minus alpha by 2. And this point here will be chi-squared with a degree of freedom, and the area to the left is alpha by 2. Now, because chi-squared is not a symmetric PDF, these are not equal. Alright? Okay. Now, in the next slide, I will show you how to read these percentiles of a chi-squared distribution. Right? So, for that, there is a table. There's a table for the chi-squared distribution. I think I have shown you this before. Examples 1. Suppose you want to read the percentile corresponding to a degree of freedom of 1 and probability of 0.01 to the left, right? So if you read this, the degree of freedom column, which is 1, and then you look for 0.01, which is 0.000. Suppose you look for the percentile corresponding to a degree of freedom of 1 and a probability of 0.99. So this, you look at degree of freedom of 1 and the probability of this, which is 6.635. And the third example is, suppose you look for a percentile for a degree of freedom of 10 and a probability of 0.95. And this will be, you look under this row 10, and then you look for 0.95, which is this one. So it will be 18.307. All right. So just to summarize what we have done, I have shown you how to read the percentiles of the three distributions: the normal distribution, the student's t distribution, and the chi-square distribution. So that completes the video, and in the next video I will talk about how to construct confidence intervals and the basic principles for constructing confidence intervals, right? Because confidence intervals are important because normally people like to have an interval of values for like for example, if you're looking at the temperature at Manchester right now, it's difficult to give a point estimate like say 20 degrees or something. It will be more meaningful to give an interval estimate like between say 20.5 and 20.9. That would be a more meaningful answer than just giving a point estimate of 20 degrees centigrade.